Hello everyone. On the last runs, we have discussed about the hydraulic turbine transfer function, and then we have discussed about the linear and non-linear turbine model. All right. So today we are going to discuss about the governor. Okay, modeling of a governor for hydraulic turbine. All right, governor for hydraulic turbine. Now, what is the working of the governor? First of all, this is the point which we need to understand. So simply the working of the governor is the governing system or governor is the main controller. All right, governor is the main controller of the hydraulic turbine. Okay, the governor varies the water flow through the turbine to control its speed or power output. When the speed is going to control, then the power output is going to control. All right, so the uh, generating unit speed and system frequency may be adjusted by the governor. So governor is the very important part of the entire system, in which simply controls the speed of the water and the power output, and likewise it controls the generating unit speed and the system frequency. So this is a simple working of the governor. Okay, so let's move forward. So this is the simple diagram of the hydraulic governor, in which this is a mechanical controlling is there. So speed governor is essentially a mechanical transducers, okay, which transform the shaft speed into the position output. So here you can see that here is a fly balls. Fly balls are this is simply connected to the turbine position, and as the turbine is rotating, they are rotating in the same manner. Okay, so the speed of the fly balls the rotation will show you the speed is increasing or decreasing. So we have taken this omega as a speed of the turbine as a reference, not as a reference but actual speed of the turbine. Okay, so omega is simply the rotor speed, which is converted into the linear displacement by means of a centrifugal forces opposed by the spring. Here the spring is connected. All right, so the speed governor output is compared with the speed reference determined by the speed changer position. So here we have taken the reference speed over here. Okay, so hello, assalamu alaikum. Hello, hello, आ रहा हूँ एक मिनट रुक जाओ. समीर, तुमसे नहीं कह रहा, समीर। समीर, तुम ले जाओ बाइक में, जरा क्लास ले रहा था। So from here you can understand that we have the speed omega over there, rotor speed, okay, and we are giving the reference speed from here. From here we have given the reference speed, okay. When the uh, droop compensation is over here, sigma delta g, this is the droop compensation we are providing from the speed adjustment, and it is a speed droop, and from here we are giving the speed droop compensation. Simply uh, from here we are doing the speed adjustment, and with the help of both speed adjustment and the speed droop controller, we are providing uh, the permanent droop compensation, okay. So here omega reference minus sigma delta g is coming, okay. So now here is a gate servo motor. Gate is moving right or left. According to that we are getting g over here. This is being connected to over here speed droop. Speed droop over here is connected over here to speed adjustment, okay. So as your turbine is moving, this mechanical system is connected like here. And this one over here, pilot valve is getting whatever the speed is over here, and according to that we are adding or decreasing the water input in that. So this is the pilot valve. Pilot means driving simply, so the pilot valve is simply connected to the pilot servo motor, and it is connected to the relay, which is giving signal to the gate servo motor. According to that, we are moving the position of the gate or adjusting the position of the gate. All right, so this is the whole working, how we are controlling the gate position. Okay, so these are the levers connected to each other, and with their motion we are connecting the whole system. The speed we are connecting, and according to that, the signal is coming, and with the movement of the lever we are adjusting the pilot valve, and then pilot servo motor, as I have already told you, then relay, then gate servo motor. Okay, so this is the closed cycle. According to, in this manner we are just controlling. So from here you can see that the transfer function of a relay valve is here, okay, and the gate servo motor is here. Okay, so gate servo motor is here, relay valve is here. So you can see that what is the transfer function of this? G upon A, G upon A. G is here, okay, A is over here. So G upon A should be equals to K1 upon S. Okay, and the transfer function of pilot valve is here, and the pilot servo motor is here. So the transfer function of pilot valve to pilot servo motor is simply K2 upon 1 plus S TP. Okay, where K2 is simply determined by the feedback lever ratio. K2 is determined by feedback lever ratio, and TP is simply what? TP is the port area of the पायलट वॉल्व का पोर्ट एरिया है. ठीक है, so let's rewrite these equations over here, that the transfer function of relay valve and gate servometer. So the transfer function of a relay valve and the gate servo motor is G upon A equals to K1 upon S, and the transfer function of pilot valve and pilot servo is A upon B K2 upon 1 plus STP. Okay, where K2, I have already told you, K2 is simply determined by the feedback lever ratio, feedback lever ratio, and TP by port areas of pilot valve and K2. Okay, so in this manner we can determine these. Let's consider this as equation number 1, this as equation number 2. Okay, so combining both of the above equations, combining the above equations, we will get what? G upon B simply goes to K1 K2 upon S 1 plus S TP. Okay, this is equals to Ks upon S 1 plus S TP. Okay, where Ks is what? Ks is simply servo gain, and TP, as I have already told you. Okay, and it is also called as pilot valve time constant. Pilot valve time constant. Okay, the servo gain Ks is determined by the pilot valve feedback lever ratio. So we assume that, refer to the figure, you must have seen that, assuming that the dashpot fluid flow through the needle valve is proportional to dashpot pressure. So the dashpot transfer function, the dashpot transfer function is d upon g simply is equals to rt str upon 1 plus str. Okay. So the temporary droop rt, temporary droop rt is determined by the lever ratio. Okay, and the reset or washout time tr, this is not tp, this is tr is determined by needle valve setting. Okay, since the water is not a very compressible fluid. Okay, so if the gate is closed too quickly, it could burst द पेनस्टॉक. उसका जो प्रेशर होगा उसकी वजह से पेनस्टॉक आपका बर्स्ट हो सकता है. ठीक है, सो उसकी वजह से क्या करते हैं, द गेट मूवमेंट इज अ वेरी रेट लिमिटेड. उसको आहिस्ता आहिस्ता बंद किया जाए तो ऑफन द रेट ऑफ द गेट मूवमेंट इज लिमिटेड इवन फर्दर इन द बफर रीजन. जब पूरा बंद होने वाला होता है उस वक्त भी हम उसको बहुत स्लोली बंद करते हैं. ऑलराइट, सो द गेट मूवमेंट इज वेरी स्लो. So you can see in the block diagram the full representation of the transfer function of each uh, we have calculated earlier in a final form. So the block diagram representation of a the full governing system is being shown over here. Let's see that. So here in this represent block diagram representation, we have shown that here the reference speed which we have taken over there. Here we have taken the reference speed. Okay, omega r is the actual speed of the rotor rotating, and the difference of that is going on there. So in the feedback system, we have taken the permanent droop, whatever the permanent droop was there, the transient droop, the frequent drooping is going on there. Okay, the sum of that is going over there in the summation. Okay, so the difference of both of them, the droop system and the speed, we are giving to the closed loop. Okay, so this is the pilot valve and servo motor transfer function we have calculated. It is that. Okay, r max and r max open and r max close. This is simply the maximum gate opening rate and maximum gate closing rate. Okay, so this is a maximum gate position, and this is the minimum gate position. Both the position we have taken, and then the transformation of gate servo motor. Okay, so gate servo motor. So finally, it is giving G over there. So we are controlling in this way the we are simply the gate opening and gate closing is being calculated in such a manner. You can see in this closed loop system. Okay, so this is simply the controlling of the hydraulic